Here we are in section 7-1 with exercises 1 through 12, and we're told to simplify each expression. We're using here the rules of exponents, the same rules from chapter 1, but now we have fractions involved when we add exponents, subtract exponents, or multiply exponents. We know how to add, subtract, multiply fractions, and so we should be able to follow those same rules through. Let's start. Anything to the 0 power is the number 1. So this is just t to the 4th times 1 gives us t to the 4th. Good. Number 2, r times r cubed to the 2nd power. That's a power to a power rule, so that becomes r to the 6th, r to the 7th, and an r to the 1st. So that's going to come out to be r to the, this is now multiplication, which means the exponents add. Good. That was a good review of those couple of rules of exponents. The next one. Okay, we have a to the 5/7 b cubed times a squared b to the -7th. Ooh, so when we're multiplying these, this isn't plus. We're not going to be distributing anything. It's just straight multiplication. So a to the 5/7 times a squared, we've got to take 5/7 plus 2. Remember, multiplication leads to addition of fractions. So this is over 1, so times by 7 times by 7. 5 plus 14 is 19. A to the 19 sevenths. B to the, let me see. Now we're going to add this. 3 plus -7 is -4. What do negative exponents do? They flip down to the bottom. So we get a to the 19 sevenths, or whatever that means, over b to the 4th. And that is our answer there. Good. Number 4. Here we have division, which means we're going to be subtracting. Now notice you could either do h to the 7 minus a -4 gives you h to the 11th, or you could take this and flip that up to the top and have h to the 4th and h to the 7th. Either way, you get h to the 11th on the top. Okay, what happens with this f? Looks like this negative exponent gets flipped down to the bottom, and we have an f to the 3/2 and an f to the 7/2. And what happens when those two get put together? This is the multiplication rule, so we've got to add these exponents. Let's go over here and take 3/2 plus 7/2. Oh, that's nice. That's 10/2. That's 5. So the end result is h to the 11th over f to the 5th. Good. Number 5, q to the -8 over q to the -12. Couple of different ways to view how to get this answer. The first one is, this is division, and by the division rule, we would take -8 minus a -12 to equal q to the 4th power. If you would like to move those negative exponents, you'll get the same result, but if you took this guy, q to the -12, and moved him up, and q to the -8 and moved him down, you would get q to the 12th over q to the 8th. 12 minus 8 still gives you a q to the 4th. Either way would give you the same thing. Let's go ahead and circle that. Number 6. This is just a division rule, so we're going to be subtracting. So we've got to do 4/3 minus 2. So that's 4/3 minus 6/3. Again, common denominator, times by 3, times by 3. So 4/3 minus 6/3 is a -2/3 power. So this is going to equal m to the -2/3 power. And what does a negative exponent do? Puts it on the bottom. So this is 1 over m to the 2/3 power. Negative exponents are not considered simplified, so you should either evaluate them or move them down to the other part of the fraction. All right, number 7. G to the 7th squared. So this is a power to a power rule. We're going to multiply those two, and we get g to the 14th times g to the 5th. This is the multiplication rule, which means we add exponents. That's g to the 19th power. Good. Number 8. 8d to the 7th to the 4/3 power. So this 4/3 gets applied to everything in here. So that's 8 to the 4/3 power. And d to the, this is a power to a power, so this is 28 thirds. Okay, so far so good. This is one we can evaluate. So this is the cube root of 8 to the 4th power. So remember, this is a root and a power. So the cube root of 8 is 2. So this is 2 to the 4th power, d to the 28 thirds, equals 16 d to the 28 thirds power. There we go. Ooh, have to do a little practice on those to make sure we can get stuff like 8 to the 4/3 power. That may take a little practice there. All right. Next we have, which one is it? Number 9. Okay, so the -5th power applies to everything in the parentheses. So we get 6 to the -5, x to the -5. So that's going to be 1 over 6 to the 5th, x to the 5th. Ooh, I don't know what 6 to the 5th is off the top of my head. Stick that in a calculator, and I get 6 to the 5th power is 7776 x to the 5th. All righty. Number 10. This -3 power should go to both of them. So I get a 2 to the -3 power. And this is c to the 8th to the -3rd power. So that's a power to a power. That means we multiply them. This is c to the -24 power. So the negatives, this guy will now flip to the bottom. So we'll get a 2 to the 3rd power, 2 cubed there, and a c to the 24th up on top. Well, the c to the 24th stays there, and 2 to the 3rd power, 2 times 2 times 2 is 8. And that's where we get that one. Okay, great. Next one. Number 11. Apply this power 2 to both of these, and we get m to the 8th over n to the -6th. Again, power to a power multiplies them, and then this negative exponent moves up to the top. So we have an m to the 8th, n to the 6th, and that's it. That's as simplified as that one can get. Ooh, number 12 looks like a big one. So let's go with, let me see, how are we going to do this? The -4 has to be applied to everything. I guess you could have simplified the k and the j's with the division rule ahead of time. That wouldn't have been bad at all. Let's go ahead and do these, though. So we get a 9 to the -4, k to the -5 to the -4. That's the power rule. So we're multiplying. That's a positive 20. Multiplying those exponents. Notice the -4 doesn't times the 9. It's not a -36. This is a just an exponent, but when you have an exponent to an exponent, that's when you multiply. J to the -12 over k to the 3/2 times -4. Let's go down here and write that down. 3/2 times -4. That's over a 1. That's -12 over 2. That's a -6. So this is k to the -6, and then j 2/5 times -4. That's just a -8/5. Okay, let's start moving stuff around with those negative exponents. So this guy goes down to the bottom. That guy goes up to the top, and this guy goes down to the bottom, and that one goes up to the top. Okay, so everything moved except that k to the 20 up there. Let's give ourselves just a little bit more room there. So we have a 9 to the +4 there, k to the 6, k to the 20. Okay, so far so good. And then we have a j to the 8/5 power and a j to the 12th right there. So it looks like the only, so the k's combine. And that's the multiplication rule, meaning we're adding exponents. So this is going to be k to the 26th over 9 to the 4th power. Ooh, I don't know that one off the top of my head. Plug that in a calculator and you get this 6561. All right, so the j's. This is the thing. So we're at the division rule, and we're subtracting. If we take 12 minus 8/5, we'll end up with a j on the bottom. So we've got to do 12 minus 8/5. Let's come over here. 12 minus 8/5. Common denominator, that's a 1 times by 5 times by 5. That's 60/5 minus 8/5. So that ends up as 52/5. And again, the bottom one wins. If we would have subtracted 8/5 minus 12, we would have been negative 52/5 and put it back down on the bottom. 52/5. Wow. That was a little bit more involved. Good.